I have a present for Cam. I call him Cam and Gar. When I would go to his office, he had all these puzzles sitting on his desk. It was quite intimidating. And so what I decided was to find a really difficult one and put it on his desk.
Thanks.
Dr. Lynn Peterson was also on my committee, and she's here. Dr. Peterson. And that is my son, but he's now 23, so you can imagine how long ago this was. We're going to have a little fun, okay? Hopefully there's a little bit of fun while you're watching the slideshow, because when I taught here, I was always teaching a couple of different classes. One was like control systems or microprocessors or AI or something like that. And the other class they always put me in was either 2301, but at the time was the one for first year students to try to get them enthusiastic and on the right track. And the other one, when the legislature in Texas required teachers to go back and get a computer certification in order before they went back to school, I would go into one of these largest auditoriums on campus in the engineering college, you imagine, okay? And there'd be 100, okay, usually young and middle-aged female teachers that would be horrified about the fact that they, first of all, had an 8 o'clock in the morning class. Secondly, that it was completely across campus. And so it set me up for total failure from the very beginning. And when the class was small, what I'd do is I'd take all the chairs and I'd turn them backwards. So when they came into class, the people that normally sit at the back, I would then walk in to the front and I'd tell them to turn their chairs around, and now the back people would be at the front, and they didn't like that either. But what I did also is I played music, and that right there, how many people know Pink Floyd, Dark Side of the Moon, that album? Like everybody in the world, right? Okay, so who was the engineer on that album? Anybody? Alan Parsons. And that music that was playing is from Alan Parsons' project, iRobot. Very cool music. And what I did was I had, back at the time, I actually had to scan these slides last week in order to get them into the presentation, because I had them as slides in a projector that I would carry to class. Okay? And I would just put that music on and put that stuff up, and if people came in early so that they could get a parking space, it would just be calming and technology and also art. And so it really was a good way for me to start this presentation, because that's what this is about. Because I believe that we're about to go into a new epoch. And I'll explain what that is in a second. So this slide is about my sister, who she got her BFA at Baylor and then an MFA at UT in art. And then she went to Cranbrook Academy, and then she went to Sorbonne. So she was a real artist. And she wanted to collaborate with me on a project called An Artist's Christmas. And she didn't really have a strong math background, okay? But she really liked the idea of double helix spirals, and she did a lot of drawing in that arena, and duodecahedrons, like Bucky Fuller used to talk about, and how it was really, you could make everything out of that, and the geodesic dome that he invented, and she was totally into a lot of that stuff. And she said, and she had all these sketches, and she said, wouldn't it be cool if we could build a spiral tree for an artist's Christmas? And then they would auction it off and make a bunch of money for the Girl Scouts in Fort Worth. Well, it happens, and part of this talk is about connections and how it's just crazy in my life of the different people that connected and the different technologies that connected in my life. Sometimes for no possible reason that I can think of. Well, I had a friend who happened to have a company in Pennsylvania. He was my best friend in California in high school. And he had a company called Conveyors Incorporated. He had a company out of Pennsylvania that basically made sludge moving equipment. And he happened to come to the sludge moving equipment waste company in the world, which is in Mansfield, Texas. Who'd have known? And he invited me down to have lunch, and I said, great. What time do you want to be there? Oh, just come in and, come to Conveyors Incorporated. And so the short version of the story is while I was there, I walked in and they gave me a tour, and there was a dude sitting on a huge piece of equipment, taking steel inside of it, and it had a sort of a cone, and as he pushed the steel in, it made a conveyor. But the radius was the same the whole way, and I looked at him and I said, hey, what happens if you turn that wheel? And he goes, well, it's kind of stupid, but it would basically change the radius. And I go, that's exactly what I need, because I'm trying to build a tree for my sister. And the guy goes, you're crazy. And this is what resulted. Those are dodecahedrons, okay, and other geometric things with a double helix that tops off at the tree. It's 7 feet tall. Well, the story of my sister starts here after that, which is the fact that she couldn't really get a job when she graduated because she, like me in the early days, took a class for artists at Baylor, and what did they use? Punch card. Everybody's looking. Most of the people out there go, what the hell is that? Okay? It's a punch card. Okay? And I'll get back to my part of this in a minute, but she learned nothing about computers. And she was in the world that was changing from a paradigm standpoint directly into computers, that was computer graphics, and she had no preparation for it all. And we were going through a huge disruption from a job standpoint, and the only job she could get was teaching people in Austin, 700 kids in the elementary school, and she had a budget of $1,000 for their art for the entire year. Okay? She got accosted 3 times in school, and finally I drove down and picked her up. I brought her here. And I put her in 4 classes in 4 different departments. And one had a computer class in the foreign language department. The lady that taught it was amazing. And she also took my class. Okay? And and then she got a job at ARI, at the time it was called ARI, and the Robotics Institute, and she got a job working on the space station, drawing things by hand. Okay? And then I got her to go to SIGGRAPH. And then I put her through this sort of boot camp for like 7-8 months, okay? And she would go up and she would find some graduate students and drink a bunch of wine and have fun looking out over from her apartment, which was my apartment. And you don't move your sister into your apartment, trust me on that one, okay? Well, the crazy part about it is that she was able to learn AutoCAD, and then she got a job at Autodesk, and she moved to Sausalito. And then from there, she took a job with a company called InGolf, and she moved to Santa Fe, New Mexico. So, the only place she's missing is Boulder, Colorado, right? Okay, so she was hugely successful relative to that from a graphics standpoint. She turned the corner through a system, and you know what? That's about to happen again. My dad was very similar, but he had the unfortunate thing of choosing an industry right before it went into decline. Okay, so the first job that he worked with, he was a fighter pilot in Korea, flew off carriers, cool guy, tough as nails, very smart. Went to the University of Michigan, had like 3 degrees, but not a PhD. And he took a job working with Chrysler and then with Wernher von Braun and the Redstone project. And they did for his master's thesis, he did the ablation shield that protected the Apollo astronauts, the Mercury astronauts, and other systems that bleeds off when you come back into re-entry in order so that the astronauts don't burn up. And then he took a job from there, from the aerospace industry, because they killed the aerospace industry after Apollo. But before that, he was the project manager of the first and second Mars lander, Viking. okay? So you'd think that from a career standpoint, he'd be kind of locked in. No. Sorry, see you later. So his next job was, because the big thing that was going up in the early 70s was environmental. And so he joined Envirotech as the vice president of engineering. It was in Bay Area, thank God for me. And for him, he grew that company until he had to leave because the environmental thing, federal government basically said, no, we need to go into energy. So he said, okay, I'm going to retool myself for energy. Luckily, he was an aerospace engineer, so he could do it relatively easy, right? Anyway, the next job was with Aramco out in Saudi Arabia, and he left for 15 years with my mom. And then in Aramco, the country basically that owned Aramco decided that they were going to put all of the young Arab engineers into those positions of management. So he was gone. So anyway, he retooled himself constantly. I don't know what's going on. Oh, there it goes. There's the Mars lander. So from an art and engineering standpoint, one of the things I want you to start thinking about real quickly is this. So what's amazing about this is that several years ago, without 3D printers, it wasn't possible to make. Okay? So you got to think about it from an engineering and art perspective. What is going on? Because we're at the very beginning stage of a lot of this stuff. Come on. Oop. So, who do you think of when you think of a beautifully designed product, the whole product? Nowadays, things are integrated with your phone and all this other kind of stuff. Think about the whole project. Even the box. Who do you immediately think of that also has amazing technology? Who?
Apple.
Anybody? Apple. Everybody would come up with Apple, right? Okay? And the question is, and probably Tesla too. And you think about the SpaceX, and you think about the Tesla, and you think about the amazing product and all that kind of stuff. You know, the latest version of that car, you know, version 12, I have one. In fact, the last time I came to Dallas, I only drove it 1 mile out of the 100 miles that it takes to get here from my farm. I drove it 1 mile. Elon Musk was on a blog, or on his blog thing the other day, and it was crazy. He said, well, I'm in autonomous driving, full self-driving mode, and I'm using version 12 of the software that automatically gets down to your car, but not this one. Why? Because that was the one a year ago where he asked his programmers to take video and have it go through the huge computer that they built, 7,000 H100s from NVIDIA, okay? Process that video and learn to drive like a 16-year-old does. And this car, he drove around in full self-driving mode, and nobody had written a line of code. Is that a little scary? Well, why doesn't every product have this level of experience? Dick Marcus was my mentor. He was the chairman of the board of Neiman Marcus. His dad was Stanley Marcus. And he used to talk about the fact that, Jeff, it's not about customer satisfaction. It's about customer delight. I'm delighted every time I get into my Tesla. I'm delighted every time I use my iPhone. Why does that not happen to everything that we as engineers develop? Why is that not happening? Steve Jobs, Elon Musk. Okay, so very quickly, we're going to go through the theme of this talk, that we're going to go through a new epoch. What is an epoch? Well, there's geological, historical, scientific, artistic, and technology epochs. You could name them. I listed some of them up here for you. Well, what leads into an epic? Paradigm shifts. So, what's a paradigm? Well, things like Newtonian mechanics. Oh, feedback, feedback. Feedback, stop. Where are my audio guys? There we go. Quantum mechanics, designed evolution, directed evolution. What is that? That's the DNA stuff that's going on with CRISPR, right? Educational paradigm shifts. We're going through a huge one right now. Just look what happened during COVID. Well, we had a paradigm shift from the card, right? The reason why I brought this up here was that in California, when I was, and 50 years is not that long, trust me. So 50 years ago, I started programming, and I had my first job 50 years ago. I was 13, and I was in high school. Okay, but before that, the first programming language that I learned was Fortran, because I had a lady who was the coolest lady in the world. Her name was Virginia Kurzweil, and she was in my high school, and she was able to get DEC to donate a PDP-AD. But before that, she basically did a computer. She mostly taught typing, but at night, she would go in and be a computer operator. And she would take decks of cards, and she would take our Fortran programs and take them in and put them in behind the other decks and run them, and then she'd roll them up into a piece of paper and give them to us the following day, and we would make modifications. Here's the problem. We didn't have a key punch. But I had a paper route and these little cards that I used to find out if they had paid me or not for my paper route. And I had this punch that had this weird square thing, and it was really long because the pieces of paper were really long. So I actually wrote my first, nobody's ever beat this story. I would take a card and I would go, if I equals, right? Okay. That requires an applause. So what drives to a paradigm? I'm having problems here. Innovation. Maybe I stand closer over here. So you invent things, right? Innovation. Are you inventive? Are you creative? Okay? What are the things, the innovations that have to occur in order to make a paradigm shift? There's always a list. You can start thinking about what those are that are going on right now that's going to cause a huge paradigm shift that will probably change it into a new epic. Nanotechnology, robotics, virtual reality, augmented reality, DNA sequencing, DNA synthesis. Well, what happens before innovation? Discovery. So what are the things that drove an amazing change? I've worked in the wireless industry, and you go back and you think, oh my gosh, people at Fermilab kind of figured this thing out, and then all of a sudden, and it's same thing with X-rays, right? And you think about all the things that came out of that. Well, that was not innovation, that was discovery. This is what I think the new epic is. And as I do my talk, I want you to sort of weave it into this and see how it works for you. But I'm trying to give you a taxonomy that you can work with in this new change that's about to occur. First of all, engineering and aesthetic. Okay, pushing those two together, because we're at a time now where you'll see, and you probably already have if you've seen DALL-E 3 lately, okay? It's like crazy. Well, it needs to be systemic, imaginative, and I will post these slides so we don't have to read through them, and I'll be able to move a little bit more quickly, okay? It needs to be imaginative. It needs to be adaptive to all kinds of different people. It needs to be, and that, it's kind of that word inclusive. Everybody needs to be able to participate. I have a domain name called the other 90%. Collective. Listen to who's closest to the problem. Long-lasting and regenerative and aesthetic and technologically superior. This is the other thing that happened during the Renaissance, was that there was a family called the Medici. And the Medici family used to bring in artists and engineers and writers and all these different sorts of people, and they interacted. I love the idea of the lab that is the atelier, which was interesting because that was a number that I was going to choose for the lab that I'm building at a home in Atlanta. But the Medici effect is how much of this innovation can occur if you put the right people together, particularly from different disciplines. If you stay in your silo, and the problem with being a department that's almost 5,000 people is that it's easy to get siloed into just computer science. Okay? You never get out of the building. Yep, I have 27 patents. My son has 2. He got his first one when he was 12 and his second one when he was 14. Based on a Lego project. Oh, this is where I became an engineer. It was in 1965. I walked into the Franklin Institute in Philadelphia, and I walked across the room, and I walked into the big computer room with these big glass walls, and I wasn't supposed to be in there. And they had lab jackets on, like white lab jackets, and they were working this massive computer. And I walked in, and I had my Snoopy with me because I never let him go anywhere. And that's what I put my pajamas in when I slept. And that was Snoopy to me, right? And they talked to me for a little while, and then all of a sudden this guy walked to the back, he brought a deck of cards back over, and he put them into the machine, and out from the printer, very slowly, came this little dude here. I was 5 years old. I liked to work on HO trains when I was 5. When I was 14, I built automatic blinds because I went to HP, which was a little tiny company in a little tiny building in California, and I got that CES photocell there, and paid a couple of bucks for it, and it sensed the light. It automatic. I went to a big junkyard with a bunch of cars, and it was a 1960s Cadillac, had power everything, had power radio antenna and power seats. It was the only thing other than maybe a Lincoln Mark IV that you can find with any of that stuff. Everything has it nowadays. And then I got a light resistor, the relay, I put it all together, and I had an automatic blind when the sun came up and down. Pretty cool, huh? It was a half adder. And I also built an analog computer that really wasn't that great. It was when I won a science fair with these two things, and it was digital electronics using little 7400s, and that was the day. And the analog computer was really just a multimeter with some divider circuits with resistors where you could move the thing around, and the voltage would add or the voltage would subtract. It's kind of cool. 1971. I was 11. Come on.
Point at the computer.
What's that?
Point at the computer, not the screen.
Oh.
No, not that computer. That computer.
It's infrared? I didn't know that. I thought it was Bluetooth. Oh, well. Oh, so my heroes, Virginia Kurzweil, her name will come up in a little while. Dr. Trout, we did laser stuff. When the first lasers came out, I did a hologram. I also did voice communication over laser. This kind of stuff that Cam and I used to do too, crazy stuff. There was a TI silent writer, and I got a job at Call Computer when I was 14, and we started doing timeshare. It had an acoustical coupled modem. You can see it on the back, 110 baud, 10 characters per second. And the two programs I rewrote on a CDC was Hunt the Wumpus and Star Trek. Some people will remember that. This is the Homebrew Computer Club, which met at SLAC at Stanford, and I used to drive my bike up there because I lived not far from Stanford campus. My mom actually worked at Stanford in the admissions office, 1975, and one of the meetings at the Homebrew Computer Club, guess who showed up? Anybody? Steve Jobs and Wozniak. They showed their first Apple I at the Homebrew Computer Club meeting. You just sort of fall into these things. You got to take advantage of them then. If you just sit around and play on your phone with TikTok and all this other stuff, I mean, it's just like you're missing out on life. Oh, sorry, infrared. Brett. This was my partner in my senior design project, which was 1982. And what we did was we worked with the Easter Seal Society and Southwest Research Incorporated, Southwest Research Institute. And what we did is we took a wheelchair, a electric wheelchair, and we built a robotic arm that basically swung out from the arm that was already there and was able to open 3 different types of doors, okay? And we did it with remote control and a sip and puff actuator, okay? Because we want to, and then when we did our senior design presentation, we were actually at the top of the classroom, okay? And we had a remote control, and we started Pink Floyd, Dark Side of the Moon, okay? And dimmed the lights, turned the volume up as high as we possibly could. And we used to do our senior design presentations with everybody in our entire department. It was engineering science, and there were only 25 professors and 300 students. So it was a bit smaller than a lot of the stuff I met here. But this was a demonstration of it going through a knob door by swinging out and then controlling it. But when we did our presentation, we did it and we put Randy the Raven in the seat, and he actually drove in when the lights were coming on and the music popped up. And it was a great presentation. We had a lot of fun. In the dorm in 1978, I got an Apple II and I started hacking around on it and stuff like that. In 1979, I call this the Bubba test, okay? I actually brought the first robotics, well, actually it was the first downlink on a satellite link in IEEE's history in San Antonio, Texas, and people had to pay like $500 to see this deal, and I, on the other side, put another TV so that all the students in the IEEE, of which I was president at the time, could watch this robotics presentation, because I was crazy into robotics. And so I got all this stuff set up and got it all catered and all these sorts of things. And then I'm like calling the guys because it's like 30 minutes before this thing's supposed to start, and they aren't even there. And I'm like freaking out, just like I was earlier today when the AV wasn't working and we did, sort of this pivot. Well, at that particular thing, all of a sudden Bubba and his other brother, it's like Larry and his other brother Larry, they show up with that, okay, on a trailer, okay, and they start putting it together. And I'm thinking, this doesn't look good at all. This is going to end very poorly. And they get the dish together, okay, and it was like a 10-meter dish. I mean, no, not 10 meters. It was a 3-meter dish, okay, and they get the dish together, and then the guy's got this little black and white TV, and he's got a protractor and a compass, okay, and he starts going to Larry, and he's going, well, I think it's over there. And I'm going, oh my God, what's going to happen? And son of a gun, 30 minutes later, we got the test pattern that said IEEE, and we watched a robotics conference. And that's when I knew that satellite TV was going to take off immediately, because it passed the Bubba test. Well, start thinking about technologies these days that have passed the Bubba test. How many people have done generative art in the last 6 months? Like everybody, okay? Okay, it just passed the Bubba test. It also has what I call an awareness application, which is GPT-3, okay? And as we move on into the different generations of GPT, you realize that not only is everybody aware of it, but they're also using it themselves. And it passes the Bubba test for them to be able to do it. And it'll only get easier, and yeah, it'll make stupid mistakes, and it'll hallucinate, it'll make up stuff, and it won't get your math problems right. But you know what? There's billions of dollars chasing, $1 trillion chasing after this stuff. Well, here's another project I worked on. I was one of the engineers at Motorola right up the street in Fort Worth, where I worked on an SMR two-way radio on the left called Centaur X, and I was responsible for the software and the hardware inside of that control head. It was my job right out of college because I already had experience working on 4-bit and 8-bit microcontrollers, okay? And this was only in 1980, okay? And so I started also working on with the microprocessor, because it was the first synthesized radio, the Centaur X9000, And it was a synthesized radio. It had a microprocessor in it. We put a bus in there so you could have options. So we had like the Yip siren. There's this little guy that sat next to me. His name was Yip. And he programmed the siren, and he did the code to be able to do different kind of wails, whether you're in England or in the United States. He's a really funny little guy. And then I did the option, which is called MDC 600. It was basically a 600 bit per second protocol that we originally developed for the FBI to be able to put in information through that control head about license plate information and location, and it would go up to a database. And this is like, when? 1980? Serial bus to be able to communicate to different radios so you can control from one control head 6 different radios at different bands. Okay, and then I wrote in that MDC 600 protocol, we didn't do it with a physical phase lock loop. There were a couple of very smart dudes that were there. Tim Burke was one of them. And they basically taught me how to do phaser computations in real time on an 8-bit microcontroller that had 4K of memory, okay, and 256 bytes of RAM. And it basically worked in the frequency domain, okay? A frequency phase lock loop in software. And in fact, I was able to get it not only to do that, but to do DTMF, dual tone multiple frequency. That's the touch tone sounds, right? So we could synthesize touch tone sounds to be able to get into other cell sites. Then that became the cellular technology, which was originally Nextel, which was an SMR system. And the thing we built used much of the same software that we had designed in the SMR two-way radios when we launched the first cell phone, which is the one on the right. Now that's what a phone looks like. Yeah, you can also make phone calls with it. This is a dude that was here, and some of the professors here will remember David Gentry, okay? David was one of my first students that I worked with that was handicapped. Although I had worked with other handicapped people, I'd never worked with a student that was handicapped. And David was quadriplegic from an accident when he was younger. He's passed away now. But David was in a wheelchair, and one of the things that we used to do is we used to go out and go bowling. He loved to go bowling. Well, I realized he was quadriplegic, so it was a little challenging. And so I tried to design some stuff for his chair so that he could run it forward, jerk it, and let the ball go, and then it'd go down. And, you know, we'd have the guards on there, but that was for me, not for him. and David had a sip and puff actuator that he used to direct his wheelchair. But he didn't have anything to let out his bladder bag. And so it was always a thing where, you know, he had to ask me, and I'd go in, and he was always embarrassed, and I was embarrassed. It was all that kind of stuff, right? I wanted him to be independent. So, you got to discover, you got to innovate, and you'll change the paradigm. He also liked to drink beer, okay, which caused a bladder bag problem, okay? But he would like to go buy it himself. And these were when the bars were always this high, until he'd be like peeking up, and there was this drunk guy. And that doesn't usually happen in a bowling place, but it happens quite often. And this guy was frankly pretty irritating, and he was like pushing in front, and he didn't really see David, and he was kind of nudging him, and David, you could tell, was getting a little annoyed. And so I started, I'm a big guy, and I started walking up in order to, and you know, I bartended for a long time when I was in college, and I knew how to handle these kinds of situations. And David looks over at me, and he winks. And I go, what's going on? And so this dude was sort of pushing in, and he got just in the right position, and David went to a sip and puff actuator, and he let that sucker go. What was he going to do, punch him? Cam, you remember this. Miko transmuting surface. We were working on all kinds of crazy stuff. One was neural networks, of all things. What year was that? 1987. He started doing it long before that, and working with recognition equipment and not Digital Switch, that other company. And taking handprinted character recognition for the post office in order to recognize, and this is one of my heroes. Unfortunately, Steve passed away while we were in school here, and this is his family right here. So years ago, this is one of those, a lot like McMurrow, who's in this audience here. It's like, I'm not worthy, because these dudes know their stuff relative to these things. And they make amazing projects, and they engage the students, and it's so cool to watch. Steve had a program called Godzilla, where he had this little thing that rotated around like an elephant's trunk, with marbles tucked in the top of it, and they would launch down, and Godzilla would be remote controlled, be coming across the floor, and you'd have to actually pass the class. You had to write the code in the group in order to hit Godzilla with the marble and the whole 9 yards, right? And this is an example of that, and there's Steve right there. And is that in your house, Judy? And that's in their house, where they actually made circuits in his garage. And Judy helped these kids solder in, and she was a much better solderer than most of the students. This is the 1991 entry into the flying robot competition. And what a cool project and what a great experience. It's a tail sitter robot. 1992, I did ant colony optimization, taking nature and taking things that do. Did you know if you put ants, a food source at the top on a lattice where you've cut out some of the boards and you put ants down at the bottom, they will use pheromones to transmit information to each other and find the optimal path. And you know what? That's kind of like the traveling salesman problem, not exactly, but it is a problem that can't be solved in polynomial time. But somehow the ants figured it out. So maybe we ought to do biomimicry on some of the things we're doing. You get the connection, okay? Art and technology and nature, they need to be tied together somehow, and that's the new epic. Whoops. I'm not trainable. This is the superconducting supercollider. Unfortunately, that grand experiment died. I have a great story. I'm not going to share it with you. It ends with getting married to my wife. That's the, great part. But if you want to hear about it, maybe you go back, 15 years. I did the commencement exercise for the College of Engineering, and you can look it up and listen to that commencement exercise. That talk that I did, I spent a lot of time thinking about, and it really has some good messages in there for young students that are about to graduate or people that are still in school and they're still scared to walk through the door. I worked on life safety and control systems. I had solved some tough problems because there was more cryogenics in the world in Waxahachie. There was more electrical power that was there in order to power the superconducting magnets. There was, some of these things were 240 feet under the ground, and we didn't have MEM sensors yet. And so I had to do 2 out of 3 voting on these little oxygen cell sensors just to make sure that people, because liquid hydrogen and liquid nitrogen, where are they on the periodic table? Anybody? They're called inert gases. Guess what that means? That means you can't smell them. You don't even know they're there. You start laughing and you're dead, okay? And so we had to worry about things like our tools that were inside these things, and the electromagnetic fields were so high that they become projectiles. So if there was anybody in the tunnel that you weren't tracking, okay, or there were any tools in the tunnel, okay, that could kill somebody. I had to worry about those things, and then I had to worry about things like, if you talk to these physicists, like Leon Letterman actually came down. We didn't have any restaurants in Waxahachie at the time, but we had this place in Waxahachie which was in the lab where they would bring in lasagna. And it was like Thursdays, and I love lasagna, okay? And so I used to go down there every Thursday and eat lasagna, and I'd probably stay there an hour, okay? Well, Leon Letterman walks in, and I knew who the guy is, right? And he goes, "How's the lasagna?" I mean, like a Nobel Prize winning physicist sits down to me and says, "How's the lasagna?" And I go, "Great," right? Well, one of the things I had to worry about was the fact that if the beam got off a little bit, it could be a bad deal. And so what you wanted to do is you didn't want to have an interaction. You wanted to be able to steer it someplace else. The problem was that it was going at put a bunch of 9s together, the speed of light. Okay? And so, but it's going around a 55-mile tunnel. Okay? So what do I get to do? I got to get there before the beryllium, before the proton gets there. What do I do? Well, if a car was going around a circle and you had to get there before the car did, what would you do? I'd cut across the middle. Okay, and so we took gallium arsenide because it works really fast, and we moved across the middle, and we proved, we didn't have to put it out there because they killed the project before we had to prove it. We proved that you could get and have enough time to deflect the beam into a beryllium target so there wouldn't be a problem. Those are hard problems to solve. That's me. That's when I had hair. That was in 1993. So we got nuked from the super collider, and I got a little, that's the office when I started it. If you know the Infomart in downtown Dallas, that big white building built after the Crystal Palace, at the end of this experiment, we had 3 floors of that building.
Basic research took a heavy hit with the demise of the super collider, but a new technology the Vice President talks about is getting a boost.
As we prepare to enter the new millennium, we are learning a new language. It will be the lingua franca of the new era. It is made up of ones and zeros, and bits and bytes.
Jeff Smith designed safety control systems for the SSC. Joe Bush was a communications specialist. Laid off last week, they now travel Al Gore's information superhighway. They co-own On-Ramp Technologies, a firm for computer users to tap into a world of information.
I've just been looking for a link into a card which is at the University of North Carolina, which is pictures of the Dead Sea Scrolls.
Type a few words, wait a few seconds, and bingo. You get a copy of the Dead Sea Scrolls on your home computer. You can even dial up a list of missing children. It's internet. 2 million computers around the world all linked on a single system. On-Ramp puts your computer online with those others for about $1.25 a day and a local phone call.
Can we send a message to the president?
Sometimes you can computer talk directly with authors, researchers, even Rush Limbaugh. But President Clinton? No, but we did get a form letter back in less than 5 minutes.
Probably had Congress not killed the SSC, Joe would be finishing his master's thesis and I'd be finishing my PhD dissertation. We put both of those on hold while we get this business going, and hopefully we'll go back and finish those.
But for now, it's ones and zeros and bits and bytes and a piece of the American dream of owning your own business, even though Congress sort of made him do it. Doug Fox, Channel 8 News.
After we went public, I was part of 53 acquisitions that happened together. I was, Weekend at Bernie's, I was Bernie. I was on the board of Vario, and I was the guy that when you went in to say whether, your ISP wants to be part of the steamroller or part of the pavement, I actually used those words, we would do acquisitions of these companies, and we grew it from 0 to 700 million in revenues in less than 3 years, half through acquisition and half through organic growth. We did a lot of cool things as firsts, being innovators in that space. One was personal web pages. Too bad I didn't think like Zuckerberg, okay? We did the first ISDN backup, first flat rate billing in the United States. We also had the one of the top 5, or not first 5, e-commerce sites on the web. I did it with Dick Marcus and Ken Hughes, and we had things like munching pigs on the right. They were $300. It was a high-resolution photograph because Dick Marcus doesn't do anything unless it's exceptional. The problem is that even on a 56K baud modem, it was a huge problem downloading, like a 3 megabyte file, okay? But this was the website that we set up back then, and guess what? None of the retailers had a computer or an internet. So how did we do it? Well, we rigged up a Sun Spark station with a fax connection, okay? And we would actually take the order and they could send the order into us through fax, okay? So fax to internet. Think about it. Okay, this is a really sad story. So the dude on the right was the guy that used to sell me modems from a company called Ascend, okay? So Stan Woodward is his name. He's a very, very good friend of mine and has been very successful in the entrepreneurial career he had. One of the great decisions he made was left Ascend and became the marketing director of, at the time, AudioNet, which became Broadcast.com, that got bought for $5.6 billion, okay? But before that all happened, and this is about the time they did the IPO, there wasn't very many people in the company, in 1995, okay? But in a little bit early part of 1995, it might have been late 94, Stan told Cuban that they needed more bandwidth and he knew where he could get it from. Okay, so we had the connection that was originally into the Super Collider, but then we had the connection into the internet that was basically through May East, Metropolitan Area Ethernet East. And the team that I had was the team from the Super Collider, which was basically the IT team from UTA. I hired Joe, I hired Mike Walty, I hired all these people that everybody knows here, you know. Mark comes into my office and he wanted a 45 megabit connection. Well, guess what? In Sesquinet, in the NSFnet here, that was the internet connection. It was only 45 megabits per second. That went all the way there. And so, you know, it was like, okay, no. Because first of all, I don't watch basketball, okay? And I don't believe in this streaming thing anyway because people don't have the bandwidth on their modems. And so, you know, get out of my office. You know, like the other people that wanted to do pornography on the internet. I was like, no, sorry, not interested. Takes too much bandwidth. Anyway, that was a joke. Well, needless to say, that was a bad decision. 2001, I met Asimo. I climbed up on the stage. They were not happy. I got the picture, though, before that. I was like taken off in cuffs. I'm going to skip that one, but that is a great slide. And it's an unbelievably great Internet of Things slide that if you want a personal presentation of this particular slide and what goes along with it, send me an email because I love this slide. There's my autographed copy of The Singularity is Near by Ray Kurzweil. And I actually, my wife and I hosted Ray when he came in to do a presentation. And that's when I found out that Ray Kurzweil was actually related to Virginia Kurzweil. And part of this presentation has to, you know, this team and Dr. Woods and everything that this school has done, this is an example of cross-discipline work where you've got folks in lots of departments, just like the flying robot stuff, okay? And that's what we need to achieve and strive for because that's what the future is about, this collaboration, particularly, frankly, with DNA and biology nowadays. This is Dean Kamen. I was invited to hear him talk here and also have dinner with him. And so Lisa and I sat at a table with about 8 people. And Dean Kamen, you don't know who he is? Well, he's the guy that invented the Segway, you know? And he doesn't have an engineering degree. In fact, he didn't graduate from college, okay? But he invented the Segway. Very innovative dude. And then, he actually made his money on a heart stent. He got a patent on a heart stent, licensed it, and made a bunch of money. And then he went in and he started learning some stuff, and he's a very curious guy. You have to be curious, right? So Dean Kamen, also the best part of his career was he started First Lego League. And this year there'll be like 700,000 kids around the world that will be building and competing with robots in 3 different competitions And it's just amazing the amount of lives that he's changed through that crazy idea where I think I'm gonna get with MIT because they got this program Scratch, and I'll get with Carnegie Mellon because they're doing some other stuff in it, and I'll get with I'll call Lego up and find out if they'll help me out. And I'm gonna call the guy down in Austin that started LabVIEW, and the first program will be on and then he puts it together, and all of a sudden, it's changed the world. This is a senior design project here that Chris supervised, with eye tracking software. It's like, cool, that's innovation. That can change all kinds of things from a healthcare standpoint when you have that, or many other different disciplines. I have 3 of these robots in my workshop. It's called a cobot, cooperative robot. So Lynn and I went to a conference up in Seattle when I was working on my master's degree, and I was fascinated with the fact that you'd walk down an aisle. This is what AI was back in, 1985 or something like that, Lynn? Something like that. And I remember she and I were walking down the hallway, and there's a lot of military people there and some big brass, and they'd always have a bag carrier with them, be some first lieutenant or something like that. This dude would probably be a general. And I don't know if you remember this, Lynn, but all of a sudden the little bag carrier, he was kind of a nerdy looking guy, AI conference, with the general who was like, big buff, Anyway, the nerdy guy looks up at the general, and he said, no, the general looks down at the nerdy guy and he goes, man, this is a target-rich environment for nerd-seeking missiles. They handed out buttons that said, artificial intelligence is better than none. And I loved that, okay? And we're bringing it back, right? Artificial intelligence is better than none. But this is my son's first Lego League group, and they made these pins for their Lego thing, and they put that on there. Okay, here we go into AI. Generative AI, right? This is DALL-E 3, okay? These are not real people. These are people, and you can see the prompt at the bottom. Oh, just type it in, okay? So type in film still, portrait of an old man, wrinkles, dignified look, gray silver hair, peculiar nose, wise, eternal wisdom and beauty, incredible lighting and camera work, depth of field, bouquet, screenshot from a Hollywood movie. You hit go, and it generates that. Are we not about to see things happen? And remember, in 2022, what year is this? In 2022, none of this existed. Yeah, another one. Behind the scenes of a shooting of the moon landing, Hollywood studio, 1969, backstage photograph, astronaut actors, lighting. Bink! And that's what you get. You don't think this will be disruptive? Okay, you remember the picture of Snoopy that they printed me 50 years ago? Okay, that's the picture I got when I said, Snoopy and the Red Baron, or Snoopy in the Sopwith camel, okay, with a smile on his face. And that's what came back. And this doesn't exist, okay? This is what it generated from tens of thousands of pictures of Snoopy, including one system, okay, that now has the capability to take photographs from different angles, okay, and it'll create the 3D rendering and you can get a photograph from any angle. Minecraft. How many people have played Minecraft? Okay? So in Minecraft, there's these things called making diamonds. Okay, it takes probably a half an hour in order to figure it out. Okay? You probably have to go through 27 different things in order to kind of learn how to make diamonds, kind of a thing. Okay, so what they did was they took video from the internet, okay, from people playing on the internet where they just record video, and they took 20,000 hours of video and put it into one of these large language model systems, okay? And they basically trained it to be able to, because what does an LLM system do? It basically is a prediction, okay? You train it on a bunch of data, you take new data that you hadn't seen before, and you basically predict what's gonna happen. Well, in this particular case, they use that prediction model in order to learn how to play Minecraft and make diamonds. And then they tested it on, you can see, it learned the task, they tested it on 70,000 hours, and guess what? It did as good as the human, okay? What happened recently with Go, right? AlphaGo. So, the questions. What year did the first machine beat chess? Now, I programmed a PDP-AD in chess in 1974, and we spent 3 days toggling in, because we didn't have a teletype yet, toggling in and hitting the instruction program load button. Okay, and then I played chess again, and I couldn't find the printout because I still have it. But I wanted to find the printout of me beating chess on a PDP-AD with, the total of like 12K a core on the darn thing, and we're talking about magnetic donut core, the real core. Well, now games are getting are better and learning from doing and training themselves. That's the evolution of ChatGPT. We'll speed through that. This is an important graph that you need to understand, because this is when we went through AI winter back in the 80s. It was crazy. Okay, we'll go through AI winter again. People will get into the disillusionment phase. They'll get in the revulsion. Oh my God, this is terrible. It'll never be blah, blah, blah. Here's the problem. The problem is you know what? This time frame is now this big. So people are going to have to go through this emotional cycle and and these are people that have already passed the BUBA test, and it's all in their awareness application, and all of a sudden there will be a recovery. And what will happen at that point? There will be a paradigm shift multiplied by 6 or 7 different cascading paradigm shifts all together, that my belief, the end part, is a new technological and aesthetic renaissance. AI, that's the epic. AI, VR, add all the paradigms together, that's the epic. You got to bring in the art part, you got to bring in the social, you got to bring in the network of stuff. It's all going to happen. These are great Gartner slides. You can look at them later and analyze them, because this is the hype cycle that they went through, so that you can predict, wow, it's going to happen. But this time it's going to be much more complicated, because it's multimodal. It's more than one change, huge paradigm shift at a time, all enabled by AI. And so what enables the AI? Moore's Law. Well, what the heck's going on with Moore's Law? Well, here's an interesting little thing that I didn't know until, I started realizing when we bought the first house on Metters Lane, which happens to be like, I don't know, this was years ago. Lisa and I lived in Preston Hollow in Dallas. And, Bush moved in like, I don't know, it was probably 12 houses down or something like that in a cul-de-sac. But we moved out of that pretty soon after that. But the house that we had there on Metters Lane, okay, I went in, it had 3-phase power. Nobody would buy this house because it had the electricity, the lights and stuff just didn't work. And I wanted to find out why, because heck, I had started a company called AHA.net, Advanced Home Automation, because I wanted to get cheap Zigbee-based controllers, and I was on the Zigbee committee, and the guy that started the company I met. But in any case, that's just another story. And in that house, it had 3-phase power, and Lisa will remember up in the attic were these crazy big pieces of board with relays all over them. And what it was those turned the lights on, and you could program the thing by hooking up the relays together, and it would do a line of lights, and so you could do like what you're doing home automation now, except it was hand wired, okay? But guess who owned the house when it was built? This dude. Yeah, another Nobel Prize winner, of which, I just want to have lasagna with the guy. It's crazy what you run into if you just pay attention. So, in 1947, how many transistors were they? There was one, okay? So, according to TechnoSite's forecast, the semiconductor industry is on track to produce 2 billion trillion. How many zeros is that? Quick, it's on a test. Yeah, a bunch. 2 billion trillion. The same number of transistors that we basically manufactured all the way through 2017. Think about that. You don't think we're going through a huge, tectonic change? Yeah, so this is the graph that basically says, oh, here we're scaling up. Now, what do you notice about the axes? They're logarithmic. That's really important. If you read The Singularity is Near, which I encourage you to do, and you listen to anything that Ray Kurzweil has produced, okay, you'll realize that the why that's going to happen is that there's a bunch of this logarithmic stuff that's going to the point where it is more neurons than are in the brain. Okay, the number of you and the cost of them are so low, but we're getting down to 2 nano. Yeah, it's just okay, at that level you're down to 6 angstroms or something. So it's oh, okay, now what do you do? Well, you go vertical. You got to get heat out of there. What do? You go optical. There's all kinds of things you can do in order to make sure that Moore's law is still handling. So paradigm number 2. Massive compute. Okay, so one of the first computers that I worked on was a CDC 6600. Anybody know who built and designed the 6600? Come on, faculty. I'm sure you worked on one. It was Seymour Cray. He left the company in order to start Cray Computers. Well, who had one of the first 6300s and then upgraded it to a 6600 supercomputers in the world? University of Texas in Austin. When my parents moved to Saudi Arabia, they stuck me in boarding school up in St. Stephen's, okay? And I was a senior, and I wasn't going to graduate because I didn't have 4 years of a foreign language. I had 2 years of German, of which I made a D in. It was the only D I made in my life, and I made it multiple times, okay? And the reason was Frank Hermer, okay, who ran the class, was idle hands are workshop for the devil. Okay, and the problem was Virginia's class, which she had 6 of us in there. I could name them: Jordan Brown, Chris, Kurosaki. I mean, I could name all these dudes. Okay, and Jordan was this weird guy, and he wore, in the summertime, a down jacket, and it was red and it had holes in it. I remember Jordan; he was about this tall, and he was one of my best friends. my sister promised, because I played number one on the junior varsity tennis team, okay, and I didn't want the two people to, okay, I'm getting the 2-minute warning. Okay, so in any case, that's the Cray, and that's the iPhone 12. See that up there? That's the deep learning. That's where it's happening, where you got 2 trillion transistors on a single die, and it's driving things like the H200. So, we're coming into the end. Chip fabless, these are all the companies that are building their own chips. They're putting them through TSMC, basically in Taiwan. That's why there's a problem with the Chinese taking over the Taiwan Straits. But all these companies are designing their own chips, and you can see the people that are in there, the typical AMD, Intel, IBM, NVIDIA, but down at the right, you'll find a lot of little startup companies. But then in the top left, you're going to find out that it's also companies like Tesla that are building their own chips. Training large models, you got to team up. So these guys that are writing the large models on the right are teaming up with the folks on the left that are using the large models for the implementations. This is crazy. Probably the most important slide here for most of you that are in computer science. And that is if you look at the bottom right, you basically see that in the tests that they did with real data, folding sequences, and they did it as a whim to join the competition, okay? And then 2 weeks later, they basically said, done. So I'm done. I got lots more exciting stuff, but smart robots. Oh, by the way, see the smart robot on the left? Opening the door, it's a dog. It looks just like Brent. Walk through it real quick. IoT, MEMS, lab on a chip, ML algorithms. Look at all those algorithms. The data deluge, course VR, that's adoption. It just goes straight up now when you do adoption. And cascading paradigms, swarm, DNA was big, is big, it's part of the epic. And last slide. Oh, wait. Sorry. Okay, go watch this video on IBM quantum computing, okay? Because quantum computing is part of the next epic. But it's going to take 20 years to get there. And put on your sunglasses. Thanks very much.